Hello, today we're going to talk about how to check the color sensor. Please download the program color sensor to your robot. So after you download the program, you should see a data output like this. Let's see, I make it smaller. Oh well, okay. So what is TR, TL, FR, FL, and other stuff? So the TL, I use T is like a top, so top left, top top right, and top left, far left, far right, and far left, and P is the photodiode, and power, the ultrasonic encoder, left and right. So for the TR, so this part, so if I move it up, see the LED turn off. So this indicates there's power, but the signal sensor you may not connect it correctly. So if I put the hand there, that's how to check. So the TR 1,930. The 1 is the digital value, and the second one 920 is the analog value. If I put the hand there, it's 0 and 45. So go to the TL. Now it's 900. Now it's 0, 40. And same for the FR. Now it's 1. Let's see here. This is 1785. Now it's 040. And then this guy, and then the photo right here is 1928. And if you have you see there's a real resistor here, and you guys can change the threshold so that the light turning on and off based on this threshold. So the digital value is affected by it, but it's not affected by the analog value. And for the PL, it's 1860, and then now it's 0205. And for the power, this is a coil, and you don't get any data, because if you have a power source, you will see this voltage change. And the ultrasonic is 5 cm and the 6 cm. Yeah, so it's ultrasonic. And for the code, it's kind of different from what you see in the lab for the ultrasonic. The encoder, let's try the encoder L. Now it's -7. If I go forward, it's going higher and higher. It's this value. It's 105, and then it's going higher and higher. If I rotate the other way around, it reduces the value. And same for R. If I go forward, wait. Let me make it bigger. Okay. So it's 142. If I go forward, it's getting higher and higher. If I go backward, it's lower and lower. So this is how to check the correct signal. And now go back to the code, because I'm afraid you guys may not understand the code, so I make the videos here so that you guys can have a clear understanding of what happened. And remember, for the Mega, the pin out is different from Uno, so check the Mega pin out before. For the color sensor, this is the pin out, and for the color scheme, please follow the color scheme too, or else it's hard for me to debug. It's hard for me to debug, and also it's hard for you to compare with your team, other team. So this is the wiring, and this is the analog and digital data of the black line, and this is the pin for the photodiode, and this is the power, the coil pin out. It only have analog, it does not have the digital value. Ultrasonic, don't touch the ultrasonic wiring, because yeah, you can change these two but not the subroutine, because I modify the subroutine so that it optimized for the robot. I will talk about that later. So these two, you guys can change it, these two, if you like, or keep it the same, it's easy. Interrupt pin, this 4 pin is specialized for interrupt, so this 4 is fixed, kind of fixed. The motor drive is the red board connector, and encoder value. So all the pin out, the pin is defined up there, and now it's a setup. So I set the 0 speed to 115 to 00, and this is all the pin. You have to define the pin mode, turn on and off the LED, and turn on and off using this. The frequency is how fast you sample the data, and these two S2 and S3 is to detect the red color or the black color, I mean the blue color or the green color. You set these 2 pins. For the black line, you set it to input. Photodiode is the same. Ultrasonic is the same as the lab. The motor drive is same in the lab or output. For the encoder, I would like to talk more about the encoder. The 4 pin, I use the 4 interrupt pin, and to set up the interrupt, you have to write exactly like this. If you need more information, you go to this link. So what this line is about. So attach interrupt is to call the interrupt function. Digital pin to interrupt, it sends this pin, interrupt L1 pin. Falling is when the L1 is go from high to low, those is falling edge, then go to the counter L. That's it. The counter L is a subroutine, and same for L1. So whenever the encode, the pin of interrupt L1s go from high to low, then go to counter L, count L subroutine. And remember, for this kind of interrupt, whenever you write something for inside the interrupt code, make it as short as possible, because you don't want the interrupt is keep running and then another interrupt comes in. So you want the interrupt to be done as soon as possible, and then wait for another interrupt. So this kind of timing, if you study in a high level, the timing is really important for our programming. So the setup is done, and then go to the loop, the main loop. You guys try. It's good to chop them into different subroutine, because you don't want to have like a whole bunch of data intertwined together in the loop. And then inside it's just a 0 print out, and it's done. So let's go to the each subroutine. So the input capture is just to capture the analog and digital data. Right here. And then the motor control, I didn't write. You guys are supposed to write yourself. For the motor control, For example, this robot, right? You will use the encoder value to decide if it go forward, left, and right. So for example, if the two wheels go forward, you guys can say, okay, this is actual encoder now, and then you want the target values to be 100, for example. So this will add 100, that will add 100, and you guys can just go. The wheels can just go. It's easy. But when it goes to the rotation, you want this guy to be negative 100, this guy is 100. You can, if you just look at the value, maybe the robot just turn this one is 100 and this guy negative 100 in different rate. So the turn it will not be on site. And if you guys want to do it turn in at one spot, you have to check the speed of the encoder changing speed. So if this guy turn 10 degree per second, for example, like 10 degree per millisecond, for example, this guy should turn it at the same time. So you guys have to check the different of different value of the changing rate of each encoder. You guys will know later when you do the programming. So go to the interrupt subroutine now. So we use one pin for the left interrupt, and then when it go into the interrupt subroutine, it will check another pin, and if it is high, then it's increase. If it's low, it will decrease. So same for another encoder routine subroutine. And as you see, the code inside is really small, so keep it short. And for the motor subroutine, it just say, okay, when it turn car on side of the left side, it is the this the control. You guys don't need to look in details. It's supposed to work if you can get the robot to go forward in the previous example. And for the ultrasonic, try not to change anything there. Why? Because it's more or less the same as the code in the lab. But why I don't want you guys to touch it, because it uses the millisecond. This one is to check the system clock. If the program go to the ultrasonic, it will subroutine. It will go to check if it's done. It's not done, so it is first time. It will get the system clock and then do exactly like what the lab did. And in the lab, it's used the delay, and now it check the system clock. System clock, if it's not long enough, then it will skip. And if it's not long enough for this, it will skip. And next time, if it go back to the ultrasonic subroutine, it will check if it's done. It's not done, then it will check get the system clock and then check with the original sonic starting time. If it's long enough, then it will do this. If it's more than 12 milliseconds, it will do this. And when it's done, it will set the ultrasonic pin the value back to 1, so it is done. So next time if we go back to the ultrasonic code, it will run this part. So if you go through the program, you will know it is exactly like the lab, but I use the millisecond instead of delay. And why we don't use delay? Because when we run the delay, the microcontroller does not do anything, and it wastes the clock cycle. And also, if the robot is keep running, right, you don't want the robot stop sensing the environment. So you want the robot to keep doing something while it's running. And at the end, it's color check. I didn't write anything there. You guys should write it yourself. So yeah, so this is the description of a short description of the car sensor program. If you guys have any questions, please write in the forum. Thank you.